Hello students, welcome to the Network Pen Testing course on Pentester Academy. Now, as I mentioned during the introduction, that rather than take up information gathering, and talk about it for weeks and weeks, I would probably prefer to do it in a scenario-based way, which is we pick up a topic and take it from start to finish, whether it's information gathering, exploitation, post-exploitation, or whatever may be involved. So in this first set of videos, we will look at pen testing routers. Now, why is this important? Because if you think about it, pretty much during any given pen test of an environment, you would run into a router which could be either in front of the corporate network, on the internet, or if you're pen testing a very large network, you may even have routers inside the network, right? Now, in this video, we'll be talking about how to set up your own lab for router pen testing using an open source solution called Vyata. So, when we look at router pen testing at a very high level, we can divide the vulnerabilities into either software-based vulnerabilities, faulty by design, and configuration flaws. Now, honestly, this pretty much applies to most software as well. Now, software vulnerabilities could be things like your buffer overflows, format string vulnerabilities, and really for mature products, these are quite rare, and as soon as they are discovered, they are fixed very, very soon. Now, finding and exploiting software vulnerabilities is the field of exploit research, which we will take up later on in Pentester Academy, right? And at the very same time, to be honest, if the environment is decently patched, then there are rare chances of you ever exploiting software-based vulnerabilities. The second is faulty by design, which is rather than this being, an actual software bug, this is really a logical vulnerability which is there in the product because of maybe wrong architecture or something else. Now again, faulty by design is difficult to find in mature products and also overall difficult to uncover. You would probably have to reverse engineer the firmware, do a lot of testing in order to figure out faulty by design. Now when we take up reverse engineering later on separately, we will probably look at some ways by which you can even reverse firmware. And reversing firmwares and all of that would really be reverse engineering as a separate topic. Now, really what we would look at when we do router pen testing is configuration flaws, because this is very, very common, and the router and the routing environment is almost just as secure as the knowledge of the team implementing it. And these would be, something you may probably find more than the other two. Now, if I were to further subdivide configuration flaws, one would be attacking the administrative services themselves, like SSH, Telnet, the HTTPD server, which runs the management interface, SNMP, and all of that. And the other could actually be attacking the routes itself using routing attacks against protocols such as RIP, OSPF, BGP, and all of that. We will take up routing attacks much later. In the beginning, what we are going to focus on is really attacking administrative services. So, how do we go ahead and simulate a router? Now, this is where Vyata, a totally software-based router, comes to our rescue. Vyata has a commercial version as well as a free community edition. We will use the community edition for these videos. So let me go to Vyata's website. So here it is. Go to vyata.org. Click on Downloads Community Releases. And you can go ahead and download basically the 6.6 R1 edition by clicking on software, and that should download the ISO file. Viata.com also exists, where Viata also has a commercial edition which has a lot more features. So I think if you have probably the bandwidth to go ahead and purchase this, you can try that as well, right? But I will be using the open source free one for our demonstrations. So I've already downloaded this file. Let me go ahead and create a VM. So let me click new and let me call this Viata Pentester Academy. The type can be chosen as Linux, version as other. Click continue. 256 MB RAM is sufficient. Continue. Let's go ahead and give it the 8 GB. And there you go. Now I am using VirtualBox because VirtualBox is open source free. You can try and replicate this in VMware or pretty much any other virtualization environment. Right, so now let me click on storage. Click on the CD DVD drive and I'm going to go ahead and select Viata Live CD. This is the ISO file which we've downloaded. Click OK and then start the VM. Right, so let's boot it. So this is booting via the live CD, and in your slides I've given you a link to the quick start documentation which you can open up. So let's wait for Viata to quickly boot. And if you notice, it actually gives you a very simple prompt which basically says login to Viata. Now the default username and password for Viata is just Viata and the password is Viata. So let's type in Viata, right? And this gives you a Linux-like console. Now what I'm going to do is let's go ahead and install the image onto the disk. Right now we are running it as a live CD. So let's go ahead and install it. And to do that, you're going to type in install. And if you hit tab twice, it gives you two options, image and system. Let's actually use the install image option. Hit enter. Would you like to continue? Yes. Partition, make it auto. Install the image on, again, SDA. Continue, destroy everything. Yes. How big of a partition? Let's give it the whole thing. Would you like to name this image as something else? Let's go with the default one just by hitting enter. So here is the config file. Again, let's go with the default option. Now it's asking us for the password which we want to keep for Viata. Now honestly, we are going to be running all of this inside a VM. So let's actually keep it Viata itself, right? It's just so that we can remember it and not have to worry about writing it down somewhere. Which drive should grub modify? Again, let's just go with all the default options. And there you go. So looks like we've installed Viata. Now let's reboot the system. And what I can also do to be kind of doubly sure is kind of power it off for a second, go back and remove the live CD. This way we are super sure that we aren't running off the live CD. So let's remove it. Let me start Viata now. So now we are super sure it's only running from the hard disk. You can go with the default option. And Viata would just boot up in just a bit. Let me pause the video while it boots, or rather not. I think it's not going to take that much time. Okay, so let's log in. Viata. Awesome. Now, if you've never used a router before, to look at the configs in a router, you pretty much have to type in show configuration. And by the way, there is tab completion, right? So you see a bunch of stuff in there, such as the interfaces. It says Ethernet ETH0, gives you a hardware ID, then the authentication details, a bunch of other stuff. Now, let's go ahead and configure a static IP address for Viata or the ETH0 interface. So let's type in configure, hit enter, then type in set, hit tab twice, rather even once would kind of work. And after that, there are a bunch of parameters which we can go ahead and set. There are a bunch of parameters which you can set. You can type in set, and then you can go ahead and hit tab once, and this gives you a lot of options. We can see interfaces in there. Set interfaces, hit tab again, gives you a lot of options. Select Ethernet, hit tab again, and then say ETH0, and after that hit tab again, gives you a bunch of options. The one we are interested in is in the top one, which says address, and after that hit tab again, and as you can see, it mentions that you can mention an IP address and prefix length. So let's say 192.168.1.101/24, right? Done this. Now, in order to go ahead and have this change saved, type in commit and then type in save, right? This ensures that this is written to config.boot, so the next time Viata boots up, this is the IP address it will take for ETH0. Now, it has already gone ahead and made the changes itself, in the sense, if you do a show interfaces, you would actually see that ETH0 already has an IP 192.168.1.101. Now remember to give an IP address, which you can go ahead and reach in your LAN. Now by default, the network mode is set to NAT. Here's what I'm going to do. I'm going to just quickly go ahead and shut down Viata. It's exit config mode, click reboot. And I'm going to go ahead and change the network mode to bridged so that I can reach it from other machines on my network. Right, so click on network, let's click on bridged adapter, and I have it bridged to my Wi-Fi adapter. You can bridge it to whatever you have access to. Let's start it. And now when Viata starts up, you would actually see that it has an IP address which we've given, which should be 192.168.1.101, and then we should be able to reach it locally. So let me open up a terminal locally. Viata, show interfaces. So this basically says the interface is up, ETH0 192.168.1.101. Let's try to ping it, 192.168.1.101, and we can ping it. Fantastic, which means it's reachable. Now let's try and enable SSH to it, right? Because this interface is not the most fun one to work with. So to enable SSH, let's do set. Let's first enter the config mode by typing configure, and then let's say set service SSH, and if you hit tab, you have a bunch of options. For example, allow root and all of that stuff, and you can change the port, the listen address, and everything. Let's just set service SSH to enable, hit commit, which goes ahead and starts the SSH server, and let's hit save so that it is saved to the config. Now commit ensures that whatever you have entered just before is really committed, in the sense action is taken based on it, while save ensures that it is stored to config/config.boot, so that the next time we boot it, this configuration is applied, right? Now let's try and SSH to this IP address and see what happens. Right? And if you notice, this basically got us disconnected. Let's go ahead and remove my known hosts. Seems like there was a small problem. There you go. Now type in Viata and we're logged in, right? Maybe you guys may not have seen that error. SSH acting funny. Typically the key issue is pretty much shown even before you try and end up connecting to it. I mean, you don't get this prompt, but hey, whatever. Okay, so now if we want, we can configure Viata from this itself. So we can do a show tab, pretty much see the configuration if you want. Right, much more comfortable to view with this screen, and you can set up a bunch of things in here, right? Awesome. So hopefully you have your Viata up and running now. Play with it a little bit. If you've never touched routers before, I would highly recommend downloading Viata Quick Start Guide and playing with it. It's a lot of fun to set it up, and it's a pretty scalable solution, which means you can actually use it even in your own little lab or even on the internet if you so desire. I don't know the terms of service if you're allowed to use it on the internet, but you can read through it. Okay guys, that's all for this video. In the next video, we will try and see how we can attack the SSH service running on a router. And if you like all of the videos I'm putting out on Pentester Academy, my humble request to you, and I would really appreciate if you can please recommend it to your friends and colleagues, right? We are really trying to make sure that we can revolutionize, and I truly mean it, InfoSec training by making it so accessible and so affordable that pretty much anybody could go ahead and take it. Of course, you're free to connect with us, and rather we'd love it if you tweet to us on Twitter. We are also on Facebook, but much more active on Twitter. That's all for this video. See you in the next one. Hello all. Welcome to the Network Pen Testing course on Pentester Academy. Now in this video, we will continue with pen testing routers and see how to test for a lot of default credentials in services like SNMP, SSH, etc. Now, the first part, of course, is to turn on the services we are going to test. So let's go inside our Viata machine. Here it is. Let's log in as Viata. Let's enter configuration mode by typing in configure. And let's say set service. Now SSH is already set, so it basically gives us saying it already exists. Let's enable telnet. Let's enable HTTPS. Let's enable SNMP. And in the case of SNMP, you would need to go ahead and provide a community string. So typically most devices ship with the community string public, and that has an authorization read only, which is it can read all the configurations, but it cannot write, right? Similarly, most devices ship with community string private, which allows an admin to read-write configuration options. Now, once we've gone ahead and done this, we will go ahead and commit it and save the config. So I can go and commit so that everything starts and then save it. Fantastic, right? Now, the IP address which I had given my router was 192.168.1.101. Now, what I've done is in the exact same subnet, I have a Kali machine running as well, right? So it's really in the same subnet, running at 1.12. And honestly, it's up to you how you want to create this network. You can have both Kali and Vayata be on the same bridge network, where they obtain an IP address from the DHCP server, or you can do a ton of other possible configs, right? I'm keeping it super simple. Now, the first thing, as you would imagine, anyone would actually do is bring out our best friend Nmap and quickly scan the IP address. So what I'm going to do is I'm going to do a quick service scan on the IP address. So you have Nmap, FNSV, FNN 192.168.1.101. Let's see what Nmap tells us. Here is our best friend Vayata running. Okay, so it says SSH is open as expected. Telnet is open and looks like it probably did a banner grab or something, and it says Vayata router. That's interesting. And 80 and 443 seem to be running light TPD version 1428. So you can actually check if there are any known vulnerabilities for this version of both the light TPD as well as for OpenSSH. Interesting. Now, just purely based on this information, we can actually say that we could go ahead and search for the default credentials, and we would find it to be Vayata, with which one could end up logging on to the machine, right? You can even try Telnet, so you can even connect to 192.168.1.101. Oops, port 23, and type in Vayata, and we are in, right? This is plain Telnet, which is insecure. Similarly, you can try SSH as well. Now you also see port 80 is open, so we could go ahead, launch our browser and try and see what is available there. Seem to still have our little proxy setting from the last lab demo. So let me go ahead and change it to no proxies. And let me type in the IP address 192.168.1.101. And looks like it's redirected to an HTTPS. And this pretty much tells me that Vayata uses a self-signed certificate. So let me confirm the security exception. And if you notice, this basically brings us here. Vayata web-based management interface is available to the subscription model only, blah, blah, blah. Now, as you clearly saw, this was very easy for us to fingerprint and figure out that this is actually nothing but the Vayata router, right? Now, depending on how the admin has configured, this may or may not be that simple, right? Keep that in mind. So we've seen SSH and Telnet, and once we know the default credentials by just searching online with the information that this is a Vayata router, we'd probably end up with Vayata as a feasible option, right? Fantastic. Now, apart from Telnet, SSH, are there any UDP services running, right? And I've seen a lot of pen testers forget about UDP based services, right? So let me go ahead and run a scan for UDP, right, using the SU option and the -P for port 161, which is commonly SNMP. So let's go back to Nmap, -SU, -P, 161. And if you want, you should pretty much allow the whole UDP scan to kind of go through entirely over the entire port range, just to be sure. This is a short video, so I really don't want you guys to kind of keep waiting for a long time. Anyway, so the good news is this returns positive, says SNMP is running, and SNMP v1, which is really has a history of insecurity, right? So SNMP v1 is what is being run. Now, what about the default credentials for SNMP? This is where again Nmap comes in very, very handy. By using the -SC option, we can have Nmap try out various NSC scripts against the service which was discovered, right? So let's go back in. I'm just going to add another option, which is -SC. Run it. And we see a ton of output in here. And really, most of these are, libraries and stuff like that installed on the remote system, which we've gathered over SNMP. This is the system description. The uptime seems to be last 5.5 hours. This seems to be the list of processes running on the remote router, if you notice. And these are all the different ports, what is bound, who's connected, and all of that. And what else do we have here? Here is the list of interfaces. This can come in handy when the router would have multiple interfaces, right? So a huge amount of information. What Nmap of course didn't tell you that it succeeded in using the default community strings of public, right? It does tell you, though not explicitly. Can you see that? It's just public, so public did work, right? Now, how would we approach this problem if, let's say, that the community string wasn't public? So let me go back in here and let me say configure. Looks like we're already in configure mode. So let me go back in here, and now let me change the community string, or rather delete right. And I'll go ahead and set this, rather than public, let me set it as public 2. Let me commit. Let me save. So what I've done is I've deleted the community string public and created a new read-only community string called public 2. Now if I go back in here and I run the same scan, let's see what happens. Right? And if you notice right now, it was not able to retrieve all of that information which we saw in the previous case when we had used default credentials, right? So it's probably abundantly clear to you guys already that default credentials is a bad idea. And using the demos in this video, we've seen how to retrieve information over SNMP in case a default community string of public is put. Now, in the next video, we'll come to the second part, which is how do you brute force services like SSH, Telnet, SNMP, and all of that, right? So that's all I had in mind for this video. I hope you enjoyed this, and I would really appreciate and be very thankful if you like Pentester Academy, that you can recommend this to your friends and colleagues. And please do connect with us on Twitter and Facebook. We are SecurityTube in both places. That's all for this video, guys. Have a great day ahead. Bye-bye. All, welcome to the Network Pentesting course on Pentester Academy. Now in this video, we are going to continue with learning how to pen test routers, and we will look at attacking SSH services using dictionary and brute force attacks. Now, rather than show you just one tool which can help you accomplish the job, we will look at multiple tools which include Metasploit, Encrack, Hydra, and Medusa. Okay, so why is an SSH dictionary or brute force attack relevant or important from a router or embedded device perspective? Now the reason is most of these devices have default passwords for maintenance accounts, and a lot of times administrators, even though they may change the root or the admin password, may forget to either disable or to change the passwords of other maintenance accounts. Second, because there could be multiple administrators and all of them probably are co-managing it, you may end up having short, easily guessable passwords being put on these systems. Finally, if you've ever set up a server with a static IP and SSH running on the internet, you would probably find that this is the very first attack which happens against your system, right? Somebody would be trying SSH brute force or dictionary based attacks. Okay, so now for this attack, we'll first have to configure our router Viata, and this is the exact same Viata router which we used in the previous video. So let's go back. Let me log in to Viata, Control L to clear the screen, hit configure to configure it, and then say set, and after that we are going to create a new username admin with a password A2D2, right? A simple password, just so that we can illustrate a dictionary attack within the span of this video. Please note your password could be much longer and an attacker could really try to go ahead and brute force your system over days and weeks. So let me set that, set system, login, hit a tab in case you're forgetting what needs to be done, user, tab again, and let me put in admin, which is going to be the new username, tab again, authentication, tab again, plain text password, and now the actual password. So what we've decided to do is create a password A2D2. Go back in here, A2D2. There we go. Hit commit and save. And if you've forgotten, do a quick show interfaces to remind ourselves that the IP address of the router is 192.168.1.101. Now let's actually proceed to create the word list. Now for the word list, we are going to assume it's a 4-character password consisting of A, D, 1 and 2, repetitions allowed. So let's go into our Kali machine. And let me create the word list using crunch. 4 characters minimum, 4 characters maximum, A, D, 1 and 2. And let me store that in the file word list. So 256 possibilities. Great. Now the first tool we will use against our Viata instance will be Metasploit, and we will use the auxiliary module SSH_login. I already have Metasploit up and running to save some time. Use auxiliary scanner SSH underscore login. Let's do a quick show options. Let's change some of these. Set blank passwords to false. After that, set pass file /root/ word list. Set our host to 192.168.1.101, which is the Viata instance. Set stop on success to true. Okay, let's assume we know that, for Viata, one of the username possible is admin, which is what we are brute forcing. Of course, you can pass a list of usernames as well, but just to keep it simple, let's set it to admin here. And after that, set the number of threads, probably 20, and then let's run. So now Metasploit is trying to break in using admin and all password combinations, and it should automatically stop once we hit the right password. So let me momentarily go ahead and pause the video just so that you don't have to stare at the screen with this working. Okay, and we are back, and if you can see, Metasploit has managed to break into the server, and it basically tells us that the username is admin while the password is A2D2. Fantastic, right? So Metasploit is one of those well-maintained tools, I think, which you can comfortably and happily use for SSH brute forcing. However, there are other tools as well which can do the job. The next tool we look at is our super helpful and super friendly Hydra. And if you've seen my web application pen testing course videos, we've used Hydra quite a lot. So the invocation is simple: Hydra -l admin for the username, -P feeding in the word list which we created using crunch, then the IP address of the victim, which is the Viata router 192.168.1.101, and the service type, right? Because Hydra supports multiple protocols, so we mention SSH. Let's hit an enter. So it looks like Hydra is giving us errors, but managed to go ahead and crack the password. I found Hydra to do funny things, right? I mean, as much as I love Hydra, I think overall I wouldn't rate it as a very stable tool. I mean, I think it's a fantastic tool, but I've seen it does behave unstably at times. Let's try again and see if it gives us the protocol errors again. It does. And if you look at basically the screenshot which I have in here, Hydra did not give any protocol errors, right? Same server which is running. Anyway, the good news is it's at least able to crack the login and password. Login admin, password A2D2. Awesome. Now let's look at another tool called Ncrack. Again, Hydra, Ncrack, Medusa, and of course Metasploit can be used to crack a bunch of other protocols via brute force. So keep that in mind. These are not special purpose tools only for SSH. So Ncrack -v for verbose. From what I remember, -t is really about max speed. --user admin, p word list, and again the IP address : the port number. So 22 signifies to Ncrack that we really want to crack the SSH protocol. So let's wait for it. There you go. Admin AD. This does seem to be a false positive. And you're seeing why at times it's important to use multiple tools, right? So if I kind of go in here, let me open a new window and let me try to SSH into the router with admin @ 192.168.1.101. And if I try a D8D, it refuses, right? But if I try A1D2, hold on, A2D2, it should work. So let me type in A2D2, and there we go, right? It works perfectly. Let me run ncrack once again. And the reason I'm demonstrating all these tools parallelly is you can see a lot of times we end up believing that tools work perfectly, right? Well, they do not always. As you can again see, it did fail. And if I try the same thing with Metasploit, or rather just with Hydra, it seems to work perfectly. Hopefully. There you go, seems to work. Ncrack unusually during my tests worked perfectly, as you can see here. Right, there weren't any issues. So let me give it one more try. Okay, again it seems to be giving me a false positive. Right, so let's come back in here for the final tool, Medusa, right? Again, -H for the host, U for the username, and P for the word list. Now Medusa has a ton of options. You can try with the -M option and -D option to see the list of modules Medusa supports. The one I'm picking up is SSH, and let's run Medusa. And there are tons of options, guys. I mean, honestly, you really have to spend some time to go ahead and look at verifying each of them. There are tons of options. Let me pause the video. Okay, fantastic. After 56 tries, Medusa has done the job properly. User admin, password A2D2, right? We'll probably give one last try to our friend ncrack. And what I'm trying to show is that relying on just one tool for results is really a bad idea, right? Because tools can give false positives and false negatives. And I really think ncrack has some bug fixing to do, because again, ADA2 is not the right credential, right? Okay, so I think some of you may feel a little disappointed as to, hey, ncrack isn't working, right? But really what I want to illustrate here is there will be many cases where tools may give you false positives, like in this case, or false negatives, right? So keep that in mind, and it's always good to know of multiple tools, play around with them so that you can figure out the ones which are more stable than the others, right? So hope you enjoyed this video, and if you enjoy Pentester Academy and all that we are putting out in here, I would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community, right? We are really trying hard to revolutionize and reinvent InfoSec education, and we can use all the help we can get from your side. That's all, guys. Thanks a lot. Have a great day ahead. Bye-bye. Welcome to the Network Pentesting course on Pentester Academy. Now in this video, we will look at how to attack SNMP using Nmap, Metasploit, and Medusa. So as we discussed, the way in which you can go ahead and read and write SNMP configuration is by using community strings which have read or write capability, right? So in this video, we are going to see how you can brute force or dictionary attack a community string. Now remember that most of these embedded devices have SNMP enabled, and at the very same time, because SNMP is UDP, it is very easy to brute force, because you can pretty much do this asynchronously and keep sending out a lot of probe requests and wait for the appropriate response. And you will see that when we do the demonstrations as to how much less time it requires in comparison to an SSH brute force for the same dictionary size. So the first thing before we begin is to go ahead and set up a community string with read-only permission on Viata. So you can do this by doing a set service SNMP community, and this is the string A1D2 authorization RO. So let's go ahead and do this. You can log into your Viata system, or alternately you can log into Viata from your Kali machine as well. Right, I'm going to do this simply because I think we'll have a better screen to look at how the config is put in. 192.168.1.101. Password is Viata. Configure set service SNMP community, and the string which we will use will be A1D2. So A1D2 authorization can be read write or read only. I'm going to set it to read only. And after that, we need to remove the default SNMP read write strings, which was public and private, from the config. So we're going to do a delete service SNMP community, tab. So in this case, it's public 2, and then it is private. Commit the config, save the config. So there we go. Now our Viata is all configured. Let's log out, close the screen. Now the dictionary file which we generated is identically same to that in the previous video, right? So let's move directly into going ahead and launching a dictionary attack on SNMP. Now if you want to do this with Nmap, they have a beautiful Nmap NSC script called SNMP-brute, which is what we will use in this video. So here are the options: -su for UDP, excuse me, -P161 for the port number, N to not do DNS resolution, and then the script name SNMP-brute followed by the IP address and then the script args. So let's go ahead and type this in. So here we go, nmap -su -n -p161, and after that we basically give the script and the script args. The script is SNMP-brute, the IP address, and script arg SNMP-brute dot communities db equals then the db equals, and we feed the word list which we gave it, which we created, right? Communities db. Okay, so let's run Nmap. And there we go. SNMP brute has succeeded, and it tells us that A1, D2 are valid credentials for the SNMP service. Fantastic, right? So Nmap to the rescue. And you can do the same thing with Metasploit by using the SNMP underscore login auxiliary module. So let's jump right into it. Use auxiliary scanner SNMP underscore login. Show options. My screen gets a bit garbled because I don't have high resolution while shooting videos. Set blank password equals false. Set pass file to /root/word list. Set our host to 192.168.1.101. Set stop on success to true, and set the number of threads to 20. Okay, let's run it. Now just compare the difference in time with respect to SSH. You can see the speed at which this is moving. And practically, it just took a couple of seconds to verify that A1D2 is the community string with read-only access. Now, if you compare this with how much time it took for SSH, you pretty much are shocked, right? And the biggest reason really is SNMP is UDP, so it's much more easier to send out, concurrent packets and have, asynchronous verification. Fantastic. Now, while Metasploit runs, why don't we also look at how the packets look like in Wireshark, right? And if you're learning network pen testing, it's always a good idea to look into the packets. So ETH0 is selected. Let's start sniffing. Let me add a filter for SNMP. Let me go back in here and have Metasploit run again. And you're seeing a ton of SNMP packets being generated. And if you notice, for one of these packets, one of these packet combinations, there seem to be a response, right? 1.12 is us, 1.101 is the router, and basically what we sent is this packet, which is a GET request, an SNMP GET request, with the community string A1D2. If you remember, this is what we set up in Viata, and the router responds back with a GET response for the same community string A1D2, right? Looks like Metasploit sends out 2 GET requests with the same community string, probably just to verify that there were no false positives. And if you scroll down at the very end, you will again find that Metasploit doubly checks that this is right? Again, it sends out A1D2, gets a response, and again does the same thing. And I guess this is really the case where it basically says validating scan results from one hosts, and then takes some amount of time before printing this on the screen. And as you can clearly see, that's simply because at the very end, it once again verifies that the community string which it found is valid. Fantastic, right? I think this goes a long way to speak about the reliability the module author actually built in. Okay, so we've seen the Wireshark analysis as well. And at the very end, let's once again look at Medusa, right? I like the name. So I'm going to go ahead and run it against SNMP as well. So Medusa -m, in this case SNMP. So let's go back in here. We can close Wireshark. And if you want, you could even look at the Wireshark trace file while each of these tools are running, just so that you can compare and contrast what the tools do, and maybe even decide which one you find most reliable. So here we come. Now Medusa with a -d would give you the list of all available modules, and the good news is SNMP is available, right? So the options are really very simple. Medusa -m SNMP -h the host name. So here we go, Medusa -m SNMP -h host name is 1.101. After that -u admin. Now really the username has no role to play in an SNMP brute force, but Medusa insists that you need to have a username filled in, from what I can understand, right? So -u admin doesn't matter what you put in here really, and -p, here is the list of community strings, which was pretty much word list which we generated. So let's hit an enter. Medusa is working really hard. It's already sent out all the 256 possibilities, and here we go. It tells us account found, and of course user makes no sense. Password is A1D2. A1D2 is really your community string, right? So I think between all of these tools, I would really rank Metasploit to be better, simply because it even tells us this is read-only access, while I think Nmap and the other tools tells us these are valid credentials, but does not tell us if this is read-only or read-write, right? So from that perspective, I would rank Metasploit better. So I guess that's all I have for this video. Hope you enjoyed this video, and if you like what you're seeing on Pentester Academy, we would really appreciate and be thankful if you can recommend us to your colleagues and friends. If you work for a company, you could even consider having your company take the enterprise edition for multiple pen testers, right? Sorry for so many requests at the very end in every video. We really need your support to make this concept of Pentester Academy successful. That's all, guys. Until the next video, take care. Have a great day. Bye-bye. Hello all. Welcome to the Network Pen Testing course on Pentester Academy. Now in this video, we will continue with pen testing routers and will look at attacking the web administrative interface. Now unfortunately, the Viata free edition does not have the web-based interface available. You would have to take the Pro or the subscription edition to get that. So what I'm going to do is I am just going to use the web interface of my home router, which is close enough to what you may find on commercial routers. Now, typical home routers have a basic or a digest based authentication, while really commercial routers, the large ones at least, have a web-based terminal using forms-based authentication. Now I have covered both of these in the web application pen testing course, where you can have a look. In this video, for demonstration purposes, I will take my home router which uses basic auth. Now, where should you go ahead and create a list of all the router passwords out there? I would highly recommend routerpasswords.com, where you can pretty much select the router. So as an example, I can select D-Link, click on find password, and this pretty much goes ahead and lists most of the popular D-Link models out there, along with usernames and passwords, right? So this may be a good place to begin. After that, of course, you can go ahead and create your own dictionaries or even try a brute force attack against the router's web interface. So let me show you a demo of a dictionary or brute force attack. Now my router is located on 192.168.1.1, and it basically is a DT850W. Goes ahead and throws up this little pop-up asking for username and password. Unfortunately, I have neither, right? So what I'm going to do is, let me go ahead and start burp. And if all of this is a little new, have a look at the network pen testing, sorry, at the web application pen testing videos, where I've covered more of this in, a much more pedantic and a learner and beginner friendly way. So let's work for burp to start. Okay, here goes burp. Now let me go ahead and set up my system to use the proxy. Now in this case, the username is admin and the password is really a number ranging between 100 to 130. Now I know I've made this simple simply because this is for demonstration purposes. Of course, you can create very large dictionary and brute force lists and try on your own, right? Just want to ensure I can finish the video within a decent amount of time. So let me again try and connect. So burp intercepts it. Let me go ahead and forward this request so that we get our prompt. Let me type in admin and basically password say A, B, C, which doesn't make sense at this point because we want 1, 2, and 3. However, now to go ahead and do our brute force attack using passwords between 100 and 130, I'm going to send it to intruder. Then I'm going to go ahead to the positions, select the basic auth part, click on add, go to payloads, go to numbers, sequential between 100 and 130. Step is 1. And then I'm going to go to payload processing, click on add. As this is basic auth, I'm going to add a prefix with the username followed by colon, admin colon. And I'm going to go ahead and add further payload processing by converting everything to base 64, which is required by basic auth. Think I'm all set. Now I can go to intruder, click start attack. Now whenever the status goes ahead and returns a 200 or something else, basically a non-401, I know I have succeeded, right? So let's wait and see. And you can set up your home router with a password which you'd like to crack and then choose something in the range just so that you can test this out. Aha! So here is my little 200 OK. And if I select this, right click, say send to decoder, I go to the decoder tab and I say decode as base 64, and there you go. Admin we already knew was one of the default logins, and 123 is the password, right? Not a really secure password, as you can see. Now the best part about routers and many of these embedded devices is just with a simple Google search or even landing on the manufacturer's website, you can get a list of all the accounts on the system. Most of these routers will never allow you to create a new username. So typically you may have admin, service or some other list of accounts which pretty much remain stationary for the lifetime of the router, which means the username is a known factor, right? Okay, so really what I wanted to discuss was, as far as router web interfaces are concerned, whether they use basic, digest or forms based authentication, you can now start applying a dictionary or a brute force based attack against them and try and break in as well, right? So try this out on your own home router. That's all for this video. If you enjoy Pentester Academy, I would really appreciate and be thankful if you can recommend this to your colleagues at work or your friends in the InfoSec community. Thank you very much. Have a great day ahead. Bye-bye. Hello all. Welcome to the Network Pentesting course on Pentester Academy. In this video, we will look at pentesting routers and the aspect we will touch upon is to use SNMP for post-exploitation. Okay, so you've managed to crack and uncover the community string either via default community string lists or brute force or a dictionary attack, and you've uncovered a read-write community string. So the question arises, now what? And this is where we will look at the post-exploitation aspect, where now using the read-write community string, we can change some of the configuration on the router. So the tool we will be using to look at the existing SNMP MIB and the different values is SNMP walk. So let me take you right into the demo. Now I already have my Viata router running at 192.168.1.101, and based on previous videos, the read-write community string which was set is router-write. We can verify this by going to our Viata instance and typing in show configuration, and as we can clearly see, router-write is a community string with write access, both read and write access, right? Fantastic. So let's use SNMP walk, and as you can clearly see, there is a ton of information which is actually being fetched from the remote Viata router, right? Probably be a good idea to go ahead and dump this inside a file. So let's call that SNMP dump file. And now let me open up the SNMP dump file. And as you can clearly see, there is a bunch of information in there, right? And you would have to look into SNMP basics if you never heard of it or used it. But really SNMP is a hierarchical data structure which holds different configuration and runtime values for the router, or for that matter the device using the SNMP in question. Now many of these values are read-write and many of them are read-only, so keep that in mind. You'd probably have to look at the MIB and its specification to figure out what many of these interesting numbers mean, but really this is just a traversal via a hierarchical tree. Okay, so now that we have the MIB, how do we go ahead and change values, right? So SNMP walk basically shows us the different values available, while SNMP set allows us to change values on the router, right? Of course, this is only applicable for specific configurations which allow write option, right? For example, a list of processes which is actually fetched while the router is running doesn't make any sense to allow that to be changed remotely, right? Okay, so we're going to use SNMP set for this, and by the way, there's also an SNMP get, which is basically getting singular values using SNMP rather than SNMP walk, which pretty much allows you to actually fetch the whole MIB at one shot. Now here's what I'm doing. If I look at the dump file, I can clearly see that ISO 36121150 is nothing but a string Viata, and if you check the MIB, what it really means is you can even change this. This is a read-write value, and so I'm going to use SNMP set, give it the community read-write string, give it the IP address of the device, and then give it the specific value I'd like to change. If you notice, this is a string, and hence I'm using S to signify that this is a string, and then I can put in, let's say, hacked. Hit an enter. Now if the write succeeded, it just echoes back what it has written to you, and we can verify that by again querying the router with an SNMP walk, and let's call this SNMP underscore dump underscore file 2. If we open up this file, we clearly see that the value Viata was now replaced by hack. Now just as a conclusion, let's go back and replace it with Viata. There you go. Now let me dump this once again. And as we can clearly see, now it is replaced back to Viata, right? So I really think pretty much in this video now you know that SNMP is not just for fetching configuration details and runtime aspect, but also to change some of them. Now you would need to look into the specification to understand which ones can be changed and what repercussions can happen for the more complicated ones in which routing tables and all of those are maintained, right? Fantastic. So that's all I have in this video. Hopefully you found this interesting. And if you like all of this material on Pentester Academy, I would really appreciate and be thankful if you can recommend us to your colleagues and friends in the InfoSec community. Okay guys, see you in the next video. Bye-bye. Hello all. Welcome to the Network Pentesting course on Pentester Academy. Now in this video, we will continue with pentesting routers, and we will look at how to use other tools like Metasploit, SNMPCheck and OneSixtyOne to do SNMP audits. So let's quickly check our Viata configuration. So let me log in and type in a show configuration, and as we can clearly see, the SNMP community string from the last video is still set to A1D2 with authorization read only, right? Fantastic. Now OneSixtyOne is an interesting tool which can actually go ahead and also do SNMP brute force, and you can provide it a list of hosts as well as a list of community names to try. So let's quickly see how this tool works. Let's go into our Kali instance, OneSixtyOne, and of course most of you have already figured out that OneSixtyOne is nothing but port 161 on which SNMP runs. So let me actually use crunch to create a passphrase of size 4 minimum, 4 maximum using AD 1 and 2. Put this into SNMP community strings, and then we use OneSixtyOne with -c SNMP community string, and we can just give the host directly. We don't have a whole subnet on which we are trying. 101 is the IP address of the Viata instance, and we can clearly see within a very short duration it's already uncovered that A1D2 is a possible community string, right? Fantastic. Now OneSixtyOne is also one of the tools you should keep in mind and in your arsenal, because we've seen bunch of times that some tools might work in some scenarios and some might not. So the more you know, the better. And of course, once you understand the concepts, it's easy to even debug what is happening or what is going wrong in the background. Now, one of my other favorite tools is SNMPCheck. Now, SNMPCheck is a post-exploitation tool. And once you have uncovered either a read-only or a read-write SNMP community string, you can use SNMPCheck to go ahead and dump all of the SNMP configuration information. So let's go in, clear the screen. SNMPCheck is also installed, and all we have to do is give it the SNMP community string A1D2, give it the IP address, and there we go. Oops, the IP address needs to be prefixed with -t is the option. And as you can see, a lot of data has been dumped. You have mount points, you have a list of packages which seem to be installed on the remote system, right? You have listening UDP ports, listening TCP ports, routing information, network interfaces, list of processes running, and a bunch of other information, right? So SNMPCheck again is a lightweight tool which you can use in your arsenal when you already are in the post-exploitation phase. Fantastic. Now, no discussion is complete without our hot favorite Metasploit, and let's jump right in. Now Metasploit basically has all of the SNMP scanning modules available under auxiliary, and of course some of them are specific to systems like AIX, Cisco, etc. The ones here in between are of interest to us. Now we've already looked at SNMP_login. As far as SNMP_enum shares and enum users is concerned, this only comes in handy if basically the device in question supports these two. So if we had a Windows machine on which an SNMP client was really running, and the SNMP client had gone ahead and collected all of this information and was also providing it via server interface, then we would be able to fetch all of this info. So you can try this by installing SNMP on Windows. I'll leave that to you. Let's look at SNMP enum. Let's do a show options. So the first is to set the community string. Let me use a set G so that I don't have to keep setting this again for the next demo. A1D2. And remember, A1D2 is what is there in our Vayata configuration, right? Which we brute forced in previous videos. So remember to set this to whatever you had set in your config. Then you have set our hosts to 192.168.1.101. And I think we can just hit a run. And as you can see, we again get a ton of information which we could use, right? Pretty much the same information in most cases with, probably some changes in the formatting and stuff like that. But it does the same job, right? Fetches as much info as possible using SNMP. Now in the post-exploitation phase, we had used SNMP set to change a community string value. And this is something we would like to do here as well using Metasploit. So before that, we need to first create a read-write community string which we can actually use. So let's go into Vayata and go into configuration mode and type in set service SNMP community. Let's call this A1D3 authorization read write. Let's commit and let's save. So let's go back in here. Now we have our Vayata instance basically supporting an SNMP read-write option, which again we could have brute forced, or maybe they ended up using default values. Now let's actually go ahead and use the SNMP set module. Show options, change the community string to A1D3, which is the write string, and the OID value. So if you kind of remember, when we had done the whole SNMP walk in the previous case, so let me kind of go back to the slides from the previous video, right? We had found out all these little interesting values in here, like ISO 36121150, and that was Viata, which we had finally changed to hacked. So I'm going to use the same one, ISO 3612. So set OID to ISO 3612. .1150 and set OID value, let's say to demo, and let's run this, and we've gotten our hosts 192.168.1.101. Let's run this, and you actually see a big argument error in here. Now the problem is Metasploit does not go ahead and accept the OID value in the ISO format. So what we need to do is go ahead and change this to a format it understands using SNMP translate. So let me copy this out. Paste it in here, and this has been translated. Copy it out, go back to Metasploit, set the OID value to this, clear the screen, hit run again. And if you notice, now it worked. It's basically set it to Viata. It was Viata initially, set it to demo, and then it rechecked if the new value is demo, right? So let's set it back to Viata. Run this again, and there we go. It's reset back to Viata. So this is how, using Metasploit, you can also set configuration values, etc. using SNMP once you have uncovered the read-write string, community string, right? So SNMP translate, all of these are also there in your slides. SNMP set, something we've looked at, right? So that's all I have in mind for this video. Hopefully you've enjoyed what you're learning here at Pentester Academy. And if you have, I would really appreciate if you can recommend us to your friends and colleagues. That's all for this video. Thank you. Hello all. Welcome to the Network Pen Testing course on Pentester Academy. In this video, as part of the Pen Testing Router series, we will conclude SNMP by going ahead and looking at how to audit it with Braa and SNMP NSC scripts. So let's look at this interesting tool called Braa. SNMP walk is the example I'm going to take with it. So let's go into backtrack and let's run the tool without arguments. Pretty interesting tool, can do a bunch of things. And here is the format for the get, walk and set. Let me just go ahead and do the walk real quick. So the way you would do the SNMP walk is basically by providing the community string. So the one on my Viata is A1D2 @ IP address. port number of SNMP, followed by the OID under which I would do the walk. So .1.3.6.1. Write everything under this, hit an enter, and there we go, right? We end up seeing a lot of information being pulled from under the whole tree with the top level identifier to be 1361, right? So this is an interesting tool, again, another one which is important to have in your arsenal, and you can do a get for a single OID, a walk for a range of OIDs, and finally setting an OID to a value as well, right? I leave the setting part to you as an exercise. Keep this tool in mind. Also, you can go ahead and go to information gathering. And down here you have SNMP analysis, where you have Braa, Cisco auditing tool, Cisco torch, copy router config, Nmap, which we'll see right now, 161, which we've already seen, SNMPCheck, Nmap, of course, and a bunch of other tools which we've spoken about, right? Including Metasploit and the whole SNMP get, set, walk, and all of that stuff, right? So it may be worthwhile just to have a look at anything we may have left, because I think beyond a point, there's only so many tools which we can cover. So I'll conclude the whole SNMP assessment for routers with one of our favorite tools. SNMP set is an exercise to you, so that's where you have a blank slate. Now, as far as Nmap is concerned, Nmap, we've already looked at SNMP-brute to brute force the SNMP community string in a previous video. Nmap also does offer other interesting NSC scripts for SNMP. So let me go right in. Let me change to user share Nmap scripts. Let me do an ls for everything with SNMP. And we see a bunch of them which may or may not be applicable to us, right? So as an example, I've already said, the Win32 share services, users, etc. of course, does not make any sense. Let's start with the SNMP interfaces script. So the invocation, if we do it without an SNMP string, Nmap tries private and public, and if it fails, pretty much the script won't really run. So let's do that. So you have nmap -su -sv -p 161 -n 192.168.1.101, and after that we go ahead and mention the nmap script we want to run, which is SNMP-interfaces. So script equals SNMP-interfaces. And please note, our Viata right now doesn't have public or private, so that's the reason Nmap is not able to pull out any more information. Now, if we had managed to use SNMP brute or any other technique to figure out the community string, then we can give an additional script args, and in that we can actually mention SNMP community equals whatever that string is. So you have SNMP community equals, let's say, A1 D2 in our case. And now if we run it, Nmap beautifully displays the different interfaces available, their IP addresses, and a bunch of other information. Now, similar to this script, you have SNMP netstat. So all you have to do is pretty much just go in here and just change this script to netstat. And this will go ahead and dump the netstat information on the remote system. So we can get information like port 2280.443 seem to be on listen state on all interfaces. UDP wise, you have 123, 161, etc. Right? Finally, the other script is processes, which gives us an idea of the processes running on the remote system. This can be interesting, to check if a firewall or something like that is, enabled. Just by sometimes looking at the process name for well-known embedded devices. So interestingly, we know that light TPD is running, so you could even check for web server vulnerabilities for that. Bunch of other things seem to be running in here. Finally, the last one, which is just the system description, which is sys description or SYSDESCR. So you have SYSDESCR. Right, and we get the system description that this is a Viata VC6.6R1 release. Right. Now, honestly, guys, there are a ton of tools. I think I've touched upon some of the more important and stable ones which you should be aware of and have in your arsenal, whether you are auditing SNMP against routers, switches, or for that matter, any device, right? There are other tools as well which you should probably dig up and at least know or aware. So if you do an SNMP and basically hit tab twice, you may see a bunch of other tools in there, which I would highly recommend you try out whenever you get time and at least be aware of what it can do for you. Right? So that's all I had in mind for this video. If you're enjoying all of this at Pentester Academy, we would really appreciate and be thankful if you can recommend us to your friends and colleagues in the InfoSec community. That's all for this video. Thank you.